We've talked about specific heat, how much energy it takes to warm up water, but what about what we call the latent heat? And the latent heat is how much energy it takes to change a substance from one form to another. So this is changing phases or changing states. So if you have something like ice is packed in a crystal. Right? And if you want to change, so this is ice, but what you have to do is from liquid to make water, you have to break these free. And because these are actually joined in a crystal, these energy holding together, you have to supply energy so that these will fly off. And the energy that was supplied is called the latent heat of fusion. So fusion is when you join your stuff together. So if you are heating something up, this is the amount of energy that you need to supply to melt the substance. Because let's say heating water or heating ice to steam. So if we have a lump of ice and we've got the temperature here, temp, and we've got the energy supplied here. What we have is we go up to 0 degrees and 100 degrees, and these are in C, and the energy will just, as we heat up the energy, the ice gets warmer and warmer and warmer until it hits 0 degrees. And this slope here, by the way, this is the specific heat is related to the specific heat of the ice. Specific heat. But once it hits 0 degrees, we keep pumping more and more energy in, but the temperature doesn't go up. And what's actually happening here is as we pump the energy in, instead of warming it up, it's changing the ice into a liquid until we now have all of these whizzing around acting like a liquid. So here's ice. This is melting ice. And then once all of the ice is melted, it starts going up again that way. And the interesting thing here, of course, is, as it said, this stays at the same temperature. This is why we throw ice cubes in a glass of drink, like Coke or Scotch, whatever you prefer to drink, whatever your tipple is. As we put this in, as the ice melts, it holds the temperature at 0 degrees. So when we say that the drink is ice cold, we literally mean it's same temperature as ice, 0 degrees. But the ice is melting, changing phase. The temperature goes up to 100 and then it flattens out again. This is where it boils. So we boil the steam and then, so this is liquid, this is water. Once it all boils off, we can heat the steam up and we get superheated steam. So basically the more energy that we shove it in, warms up, melts. Warms up, boils. Warms up there. So the steam, when you boil the jug, the steam coming off there is 100 degrees Celsius. And it takes a bit of a trick to get it above 100 degrees. Either you heat it once you boil it off, then you heat it up, or you pressurize the whole system. So basically, the energy, latent heat of vaporization is boiling or condensing, depending which way you're going. Latent heat of fusion is melting or freezing. If we're going the other way, we start with steam, we lose energy, then it condenses and turns into a liquid. Then the liquid cools and cools and cools, then it freezes and then it chills down as ice. So depending which way, if we're heating up, we're melting it. If we're cooling it down, we're freezing it. Same here. We're heating it up, we boil the liquid into a vapor, If we haven't vapor and turn it into a liquid, we're condensing it. So the latent heat of fusion is going to be 300 for water, is 334 kilojoules per kilogram. To melt a kilogram of ice, all of it, melt it totally, you have to put 334 kilojoules of energy in it, which is a lot. Or, if you're freezing it, you have to remove that much energy for it to freeze. Latent heat of vaporization, it takes a lot more energy to boil stuff, so that latent heat of vaporization is 2,265 kilojoules per kilogram. As you can probably appreciate, this is for water, different substances will have different amounts. If we're talking aluminium, for example, it's going to take quite a lot of energy to melt aluminium. It takes a huge amount of energy to boil aluminium. But some things much easier, like acetone seems to boil quite easily. But you've got to shove the energy in or pull it out. So to heat something up, we're pumping energy in. To cool it down, we're pulling energy out.